So my presentation is on industrial biotechnology, which refers to the use of cells and or their enzymes to create industrial products that are more easily degradable, less energy intensive, and produce less solid waste vis-a-vis petrochemical processes. We've been using biotechnology for thousands of years, and until the 20th century, everything from fabrics, dyes, building materials, and furniture all came from plants and animals, until which time they were replaced with petroleum derivatives. But we're now seeing a shift back toward using bio-based materials, driven in large part by the desire to reduce carbon emissions. The objective now is to make these products economically competitive with those derived from petroleum. And as I will show later, making that switch from a petrochemical process to a biological process can in and of itself increase profit margins. Currently, the most common or most commercially important biotechnologically derived product is probably ethanol, which comes from fermentation. And ethanol is used as a fuel additive, though its energy content is less than that of other liquid fuels like gasoline, diesel, or even plant animal fats by at least 10 megajoules per liter. It's worth noting also that diesel can be made through biomaterials. You start with plant animal fats, and then you transesterify them, and then you get diesel. But most of the diesel that we use comes from fractional distillate of petroleum. And while we've been using ethanol for thousands of years, some new applications of biotechnology, including producing meat in vitro. So the field is huge, and it can be differentiated using terms like red, green, blue, or white, which refer to biotechnology applications in health, agriculture, or marine, respectively. And I'm going to focus on the applications to the chemical industries, or white biotechnology, or industrial biotechnology. Although the applications can span several of the categories, so the terms are not absolutely restrictive. But the principles here are to use living cells as microfactories to produce industrial chemicals, and you use biomass as feedstock instead of traditional petrochemical stock. And the field, the research started in this field focusing on biodegradable polymers like PHAs, or the polyesters of 3-hydroxy acids, which are materials like rubber. And currently, the biopolymer market represents about 2% of the global market share, which is actually up 50% since 2012. Cargill Dow, a huge chemical company, recently started producing a polymer from lactic acid, which is from fermentation. Another company, BASF, produces vitamin B12 from the fungus Sheba gossypii, which they shifted away from a complicated 6-step chemical process in order to do. The self-described world leader in white biotechnology, a company DSM in the Netherlands, switched production of an antibiotic away from a complex 12-step chemical process to one that involves just 3 steps, a fermentation step, and then 2 enzyme steps. And they report a reduction of 65% in production costs, as well as a halving of raw material costs. And then one last example, that same company, in collaboration with the French company Rocket, produced the building block chemical succinic acid via fermentation, which normally is produced, again, by petrochemicals. And they report about that, a 50% reduction in greenhouse gases as per a life cycle analysis. So why now? Why the sudden resurgence in interest in biotechnology? Well, beyond the environmental motivations, there have also been advances in genetics, molecular engineering, catalysts, and fermentation technologies that made it possible for these products to compete with petrochemicals. But they are still, in general, more expensive than products from petrochemicals. So what can be done, or what is being done to change that? Well, for one, research is focusing on starting with cheaper feedstocks. Instead of corn, which competes for use in food, use waste products like corn stalk or corn cob. Additionally, government subsidies can help, or government taxes on fossil fuel products can help here by making fossil fuel products more expensive to consumers. And in conclusion, biotechnology has already been proven to be successful in terms of reducing environmental impact while maintaining or increasing profitability vis-a-vis petrochemical processes. So it is likely that we will continue to see the shift toward biotechnological processes. So thank you